Okay, so the work problems for Chapter 2 from Brown and LeMay. This is just an introduction, basically. We're going to talk about, excuse me, naming compounds mainly. Let's go to the next slide. So for the work problems, a lot of the work problems are going to be taken either from the chemistry book by Brown and LeMay or from Zumdahl's chemistry. Occasionally a problem will be in there from McMurray and Fay's chemistry. And then some of the multiple choices are usually taken from Mr. Max AP chemistry site. Next slide. The answers are provided by myself. Next slide. Okay, so let's take a look at Chapter 2's problems. This first problem is very simple. Let me just read it. In an experiment, it was found that the total charge on an oil drop was 5.93 E minus 18 coulombs. How many negative charges does it contain? This one may look complicated at the beginning if you first look at it, but it's very easy because we know that every negative charge, which in this case would have to be electrons, right, is going to be 1.6 times 10 to the minus 19th coulombs. So all you have to do is just divide the total number of charge, which is 5.93 E minus 18, divide that by 1.6 times 10 to the minus 19th. That's how many coulombs of charge are on every electron, and that will tell you how many electrons you have. Next slide. So just divide the number that they gave you in the problem statement here by the charge on one electron, and that'll tell you how many electrons you have. It says negative charges, but it has to be electrons here. And that's all you have to do. So this is very, very easy. Let's go to the next one. All right, the naming here is also fairly straightforward. There's a few things, mainly these polyatomic ions, you'll have to memorize. And so try to do them little by little and build yourself up until maybe like halfway, 2/3 of the way through the semester. Hopefully by that time you'll know all of them. So let's do A. A is sodium and bromine. When you put them together, that's a type 1 naming situation. So it's just sodium bromide. So A is just going to be sodium bromide. So I'll just go through and give you the answers here, and then I'll go to the answers on the next slide and let you pause there if you want. Rubidium is in the first column or group, so it's an alkali metal, right? And you have to have 2 rubidiums because O is minus 2. As we mentioned in the lecture slides. If you haven't watched the lecture slides for this chapter, you probably want to go back and do that. Because it's kind of an important chapter. If you just don't have time, maybe you want to just do it sometime when you're laying in bed at night or something. Or, I mean, you know, whatever. So rubidium, you have to have 2 of them because they're +1. So rubidium 2 oxygen is going to be rubidium oxide, and that's all you put. Rubidium, oxygen changes to oxide. C, calcium and sulfur. So calcium sulfur becomes calcium sulfide. All of these are just type 1. So they're just basically main group metals with nonmetals. D, aluminum and iodine. That's the same situation, type 1, so it's aluminum iodide. You don't have to put tris or anything in there or 3s. It's just aluminum iodide. Aluminum is actually over in the 3rd column on the other side of the transition metals, over to the right of the chart in the 3rd main column, but it's still a main group element. So it's treated the same way as the things that we mentioned above. E, we're supposed to write the formula. So strontium fluoride, Sr is in the 2nd column or group, so it's going to have 2 of the F associated with it, 2 of the F minuses. So it's going to be SRF2. Aluminum, selenide aluminum is +3 because it's in the 3rd column. Selenium is in the 6th column under oxygen, so it's -2. So remember, when we have a situation where you've got one of them's +3 and one's -2, that's the way it usually happens. You just transpose those numbers. So it will become Al2Se3. Al2Se3. Potassium nitride. Potassium is +1. Nitrogen is -3. So you're going to have 3 of the potassiums to make +3. So it would be, and the symbol for potassium is K. So it would be K3N. K3N. You have to have 3 potassiums because they're just +1. Nitrogen is -3. So it would take 3 +1s to make +3 to match it. And then magnesium phosphide is another one of the 2,3 situations. Mg is +2. It's a main group element. And don't get it mixed up with manganese, because manganese is a different thing. It's a different area of the chart, so it's important to keep these straight. So magnesium symbol is Mg, and it's +2, and phosphorus is in the 5th column, so it's -3. So again, we've got this 3-2 thing. So switch the 3 over to the magnesium and the 2 over to the phosphorus. So phosphide is when you have phosphorus on the end. So it would be Mg3P2. And I'm going to go ahead and let you look at the answers and pause if you want. So next slide, and then the next one after that. So now we're on another situation of naming compounds. So A, again, this is cesium fluoride, just a type 1, just like the other ones. Lithium nitride would be B. Nitrogen becomes nitride. Lithium nitride, you don't have to put a Roman numeral in there because it's a main group element. Silver is a transition metal. So here we're getting to our first type 2. So it would technically it would be silver and then open parentheses Roman numeral 1 close parentheses sulfide. But you don't have to put the 1 in this case in there, because it's understood that silver is always going to be +1, even though it is a transition metal. So you just write silver sulfide, and that's perfectly okay. You have to have 2 of the silvers because they're +1, so 2 times +1 is +2. Sulfur's in the 6th column, so it's going to need 2 more electrons to get an octet. So if it takes 2 more electrons, it will be -2. Now, from D and then over to E, we have transition metals here and here. And if you don't believe me, just look at the chart. So for both of these, we've got O on the right-hand side. So O is -2 for most purposes. So, and also both of them, we have 2 of them. So 2 times -2 for both of these would be -4. Here is -4. Here is -4. So the Ti has to be +4 and the Mn has to be +4. So this has to be manganese, and this is manganese, not magnesium. So the way you can remember that is Man, manganese is Mn. All right, so it has to be manganese, open parentheses, Roman numeral 4, close parentheses, oxide. One more time, manganese, open parentheses, Roman numeral 4, and that's to match the +4 oxidation number, close parentheses, oxide. And then for E, it would be titanium 4 oxide. Titanium 4, Roman numeral 4 in parentheses, oxide. And for F, these are both, we're back now. This is no longer type 2. This is back to type 1. So you don't have to worry about the 3 or the 2. You just write strontium phosphide. Phosphide comes from phosphorus, and strontium is what is symbolized here by this SR. It's not ST, it's SR. Okay, next slide. And you can pause here and look at the answers. Let's go to the next slide. All right, now we're going to get in here to some polyatomic ions. Here's a polyatomic ion. Here's one, and here is one. So let's just do those first. So SO3 and SO4 are both from sulfur. They both have a -2 charge. SO3 is sulfide and SO4 is sulfate. They're both -2. So that means that for this one, it's going to be barium sulfite, A. Barium sulfite. B, NO2 is nitrite, NO3 is nitrate. They both have a -1 charge. So this is going to be sodium nitrite. C, do you remember what the MnO4- is? That is permanganate. So this is potassium and this is permanganate. The permanganate ion, it's MnO4-. So this is potassium permanganate. Potassium permanganate. D, CrO4 is chromate and Cr2O7, 2-, they're both 2-. That's going to be dichromate, so it's like you have 2 of them. So this one is the di one, so it's dichromate, and you have potassium in front of it, and so it's just potassium dichromate. So again, I'm going to go ahead and I'll go to the next slide for the answers. If you want to pause on the next slide, you can, and just look over the answers. I'm going to go on to the second slide following. And another one for naming. So the first one and the second one are from copper, and the third one is from cobalt. And the copper and the cobalt are transition metals, so they'll have more than one possible oxidation state. So we're going to have to put in a Roman numeral to show which one it is. So let's go ahead and do D first and get that out of the way, and we'll come back. So CO3 2- is carbonate. That's another one of the ones I asked you to memorize right away. CO3 2- is carbonate. So if you have a sodium in front of it, an Na, that's Latin natrium. So it's a sodium carbonate. That's all you have to do for D. For A, B, and C, because copper and cobalt are transition metals, we will have to put a Roman numeral to identify which oxidation state they have. So the way that you figure that out, iodine here is in the 7th column, so it's going to be -1. So for A, you have a -1 on the right, so you need a +1 on the left to match it. And so that means it's copper 1 iodide. For B, you have 2 -1, so that's -2. So this has to be +2. So you have copper 2 iodide. You don't change it to copper 2 diiodide, you just leave it iodide. For C, it's going to be cobalt 2 iodide. So A, B, and C are all going to be type 2. And then D is actually a polyatomic ion, right? All right, and then down at the bottom here for E, CO3, we just said in part D, right? What is CO3 2-? It's carbonate. So this is a little bit odd, so you'll just have to remember this. And I didn't give you this one in your initial list, but you'll want to pick it up at some point, like before the first test. If you have CO3 2-, it's called carbonate. For some reason that I have no idea why. If you have HCO3-, it's called bicarbonate. So, I mean, I don't know how they came up with that. It's one of the old names that just kind of has hung around. So you may be familiar with the name bicarbonate because you may have baking soda or sodium bicarbonate, or they call it sodium bicarb, in your pantry to like block odors or that kind of thing, or maybe in your refrigerator or whatever. And you also can use it in baking. So anyway, we have a sodium here, and then we have the bicarbonate. So at some point you'll want to remember that HCO3- is bicarbonate, and then the Na is going to be Na+. So this is just sodium bicarbonate, okay? So any questions you have about this, don't hesitate to email or call. F, S4 and N4. So if you look at the chart, S and N are both in the right top portion of the chart. That means they're both nonmetals. That means when they make a bond, they're going to make a covalent bond. They're going to share the electrons. So when you have a covalent bond, you have to name it differently. So however many of each thing you have, you put a prefix. So the prefix for 4 is tetra, T-E-T-R-A. So it would be tetrasulfur tetranitride. Again, that's tetrasulfur tetranitride. For G, it would be sulfur hexafluoride. And the S and the F are both from the top right part of the chart. You don't have to put monosulfur, because if there's only one in the first part, like the S here, and that's the way it is most of the time, you just leave out the mono for the S and just call it sulfur hexafluoride. For G, I'm sorry, not G, for H, I, and J, all of those are going to be polyatomic ions. In fact, J is 2 polyatomic ions. So you have NH4 plus and NO3 minus. So that's just ammonium nitrate. Back up to H here. This OCl thing, I didn't ask you to remember that yet, but that's hypochlorite, HYPO chlorite. Hypochlorite. So anytime you have OCl, or C, it's actually written ClO minus. That's called hypochlorite, so this is sodium hypochlorite. Sodium hypochlorite. So this one you can hold off on this one right here for right now, but before you take the first test or so, you should try to get that one in also. And then chromate is another one of the. So I didn't ask you to do this one, but so you don't have to do it like right away, but before the first test. if possible. The reason I say that is because I could put this problem on the first test. And then CrO4, and that's going to have a 2 minus charge, is called chromate. Remember CrO4, and these, I think I did ask you to remember these, right? So CrO4 2 minus is chromate, and Cr2O7 2 minus is dichromate. So this one's just the chromate, and then it's got a barium stuck in front of it, so it's barium chromate. So the point of this whole exercise here, from here down, this part is polyatomic ions. Next slide. And then you can pause here and look at the answers if you want. Next slide. And then write the formulas for these. A, B, let's see, A and B, and I guess that's it. Okay, so A and B are covalent, so we're going to have to put prefixes here. So to change this back to the formula, this would become SF2, which I'm not going to try to write it out because it takes too much time. So this would be SF2 for A, and B would be SF6. So the only difference between A and B, they're both covalent because they're both two nonmetals. The difference is that one of them has two Fs, so it's SF2, and the other one has 6 Fs, so it's SF6. Sodium dihydrogen phosphate. So phosphate, this is one of the ones you should remember. One of the first ones I gave you, it's PO4 3 minus. But this one has two H's in front, so it's going to have H2, PO4, and then in front of the H2 you'll have an Na. So I'm not going to write it out because it's so hard to write with this, but you're going to have NaH2 and then PO4. And you don't have to put any more charges in. I mean, you can if you want. You could write Na plus, and then you could write H2 plus 2, but people don't usually do that. They usually just write it as NaH2PO4. And then for D, you've got nitrogen and lithium. Lithium's +1. If you don't remember that, look at the chart. First column or group is lithium, and then the fifth column, you'll see nitrogen at the very top. So nitrogen has 5 valence electrons because it's in the fifth column. It wants 8. So if it takes 3 more to get to 8, then it will be -3. So you have a -3 for the nitrogen here. Now I know that says nitride, but that's because they changed the name from nitrogen to nitride to make the name for the compound. So anyway, that's -3. This one is -3, so you have to have a +3 over here to match it. But lithium is +1, so it means you have to have 3 of them to get to +3. So what would the formula be? Li3N. Li3 subscript 3N. And then E, chromium, is abbreviated as Cr, not CH, or CHR, it's Cr. And then carbonate's another one that I asked you to remember. It's CO3 2 minus, CO3 2 minus. So the formula here is going to be one of these flip-flop, transpose things where you have to flip the 3 over to the carbonate and the 2 over to the chromium. So you're going to wind up with this Cr2 and then in parentheses CO3 because that's the carbonate. It's all one thing, and that's going to be 3. Okay. So it would be Cr2 and then CO3 3. Next slide. And again, I'll let you look at those if you want. Next slide. For A here, we have sodium, which is +1, and oxygen, which is -2. So it's going to be Na2O, not NaO. Na2O, you have to have 2 sodiums because you want +2, and to get +2 from sodium, you have to have 2 of them. For B, maybe don't worry too much right now about this one because this one's confusing because it's one of these weird situations where O is not -2. I kind of wish they hadn't put that in there. So, I mean, I probably won't ask this on the test. You could see it on the final, but I probably won't ask it on the first test. Just if you're interested, it's actually Na2O2 because this is a different kind of way that oxygen bonds. You wind up with oxygen bonded to another oxygen. So it changes the oxidation number of oxygens. So, you know, just basically, I'll just tell you that I probably won't put this on the test here. And if I do, remind me and I'll just give you credit for it. And then Cn, so let's go on to C. So C is going to be potassium cyanide, and cyanide is one of the other polyatomic ions that we were going to learn, and it's Cn minus, where that's carbon and nitrogen with a minus charge, and potassium is +1, so the +1 matches the Cn minus, so it's just KCN. K for the potassium, and then Cn for the cyanide. Again, the Cn is all one word. It's a polyatomic ion. So it's just K for the potassium and then Cn for the cyanide. D, copper 2 nitrate, means you've got a +2 for the copper. Nitrate, remember, is NO3 minus. It's only a 1 minus. So you'd have to have 2 of them. Because you've got a +2 for the copper, you'd have to have 2 nitrates to match it. So it would be Cu, and then in parentheses, NO3, close parentheses, and that would have to be 2 of those. So have a 2 subscript after the nitrate. So it's CuNO3, close parentheses 2. E, selenium tetrabromide. That is going to be Se, and then Br4. So SeBr4. Next slide. Next slide. All right, now we get over into atomic structure. So here we have an unknown element that has a mass number of 79. The most stable ion of the isotope has 36 electrons, forms a binary compound with sodium, having a formula of Na2X. Which of the following are true? All right, so this looks hard, but it actually is not. So start here. If X, which is what we're looking at here, if X makes bonds with 2 sodiums, and each of those is +1, so each of these, the sodium's in the first column, so it's going to be +1, and we have 2 of them, so it's +2 for the sodiums. That means that this X has to be -2. And it says that this most stable ion, which would be represented by this formula here, by the way. So you'll want to remember that that's going to be the most stable ion, because that's where it's going to have an octet. It has 36 electrons. But what's happened here? Well, the sodiums, the 2 sodiums, have each given an electron to the X. So this is actually X2 minus. This right here is actually X2 minus, and those 2 NAs are actually 2 Na pluses. So if the X2 minus is 36 electrons, that means the X without those 2 extra negative charges would be 34. So if it were just a neutral X atom, it would only have 34 electrons, not 36. That's the key to this whole problem. So if you don't see that, you can email or just listen to this repeated a couple of times until you get it. It has 36 electrons here, but in this form here, but 2 of those electrons have been given to it by those 2 sodium atoms. So the 2 sodium atoms are now pluses. So they're both Na plus. Those 2 extra electrons went to the X. So it had 36, including those 2 extra ones. So if you took away the 2 extra ones and just made it a neutral atom, it would only have 34. So it would have 34 electrons, and that means it would also have 34 protons. So if it has 34 protons, you just look up the chart and go to atomic number 34 and find what that is, which I can't remember off the top of my head. I want to say selenium, but I'm not sure. So anyway, but whatever it is, we'll see it on the next slide anyway. So if we come down here, if the mass number is 79, and if 34 of those are protons, how many would be neutrons? So just subtract 34 protons from a total of 79, and you get 45 neutrons. So let's come down here to C and write that there are supposed to be 45 neutrons. And 34 protons, right? So if you add 34 and 45, you get 79, which is what we want. Okay, so that answers these 2. This one is wrong, and this one is wrong. And 34, I think, as I say, I'm not sure, but I think it's selenium, and they're saying it's strontium, so that's wrong. And then the compound between X and fluorine would be a covalent compound, and that is going to be true. So that's the only thing that's right here out of the 4 choices. A is true because X is going to have to be a nonmetal, and we already know that fluorine is a nonmetal, right? So whenever we have 2 nonmetals, it's going to be a covalent compound. Next, And then you can pause here if you want. Next. All right, and then the multiple choices are pretty straightforward. Number one, in the symbol below, X is blank. And so we have X, carbon, and then 13. So remember, and I'll let you think about this for a second, X is going to be the atomic number. So think about what it stands for here. And then 13 is going to be the atomic mass. So we're looking for X. It's going to be the atomic number, right? So look for the choice that has, and that's going to be D. Next. Cathode rays, remember we said that Thomson was dealing with these. At first they thought they were some mysterious ray. Then we know now that they're just electrons. So we mentioned this previously. So this is going to be C. Next. Chlorine and chromium form an ionic compound, and it's called CrCl3. So this is going to be chromium chloride, but you have to, because chromium is a transition metal, you have to put in a Roman numeral here. So you want to figure out what Roman numeral to put in here. So chlorine's in the 7th column, so it has 7 valence electrons. If it wants 8, then if it takes one more to get 8, it would be -1. So 1 chlorine in its becoming chloride would be -1. But there are not 1, there are 3 of them here. So that's 3 times -1. So on the right-hand side of this thing, we have -3. Let me try to draw a line here. So on the left-hand side, since this is a neutral molecule or formula unit, we want +3. So we write this as chromium 3, Roman numeral 3, chloride. Now you don't have to put trichloride, so watch this. This is a trick question. This tri part right here doesn't go here because this is an ionic compound. The tris and dis and tetras are only for covalent compounds. So the answer is going to be C, chromium 3 chloride, not trichloride. Next slide. Which isotope, remember isotope's the same thing, copper or whatever, with different numbers of neutrons. So that means the bottom number, the way they have it written here, for most of these, they actually flipped these, and some charts actually do that. So let's just say the smaller number should be the same for both of them, which isotope has 36 electrons. So in this particular case, in an atom, that means that we have a neutral atom here. So if it's going to have 36 electrons in a neutral atom, that means it's also going to have 36 protons. So that means the bottom, or not the bottom in this case because they're switched here, but the one that is on the bottom in most of these cases is going to be the number of protons, and that's going to be answer choice A here. So A is going to be our answer because it has 36 protons. Next slide. Which pair of atoms constitutes a pair of isotopes? So we're looking for something that has the lower number, the bottom number is the same, and the top number is different, or the larger number is different. What we're looking for here would be something like what we have in A here, where the A, where the number of protons here is the same, and the number on top, which is the number of protons plus the number of neutrons, is different here and here. So that would be an isotope. That's a pair of isotopes here. So A is correct. These two here and B are not the same element. They're different elements, and the same thing here and here and here. So all of these are just different things. So the answer is going to be A. Next slide. In the periodic table, the rows are called periods, and we didn't talk about this, but the reason they're called periods is because every time you come down to another row or period, then the properties of the things in that row will be similar to the things directly above each element. For example, the things in row 3, in the first column of row 3, will be similar in chemical properties to the things in the first column of row 2. So that's referred to as periodicity, and we have a whole chapter that will deal with that. But so anyway, the things in the rows are called periods, and we've already said that the columns are called groups. So we're looking for periods groups, and that, again, that's answer choice A here. Next. This is carbonate, CO3 2-. This part of it is carbonate. And as I said before, if you stick 2 H pluses on that, it becomes H2CO3, and that's just carbonic acid. So you'll want to just maybe memorize that. It's carbonic acid. That's one of the acids that's in like Coca-Cola. Next slide. Next slide. Oh, here's a picture of it if you're interested. So the thing in the very middle is the carbon. This is the carbon, and then these are the 3 O's, the red spheres, and then these are the H's here on the ends. Kind of an interesting structure. Next slide. The correct formula for molybdenum for, I don't know if I said that right, hypochlorite, is going to be C. And the reason is because the ClO hypochlorite, the hypo means it's one less O than chlorite. Remember, Cl was the one that has 4 different possibilities, so it's kind of weird. So it doesn't just have chloride and chlorate, it also has hypochlorite and perchlorate. So the one that we're looking for is the ClO. So let's just look at these other ones. This one is chloride. This one that I'm underlining right now, that Cl is chloride. ClO4 is going to be perchlorate. ClO2 is going to be chloride, and ClO3 is going to be chlorate. Okay, and they all have the same charge. They all have a negative charge. So our answer choice is going to be C, because that ClO right there is hypochlorite. That's hypochlorite right there. So, I mean, all of the things fail, just memorize it. So the answer here is going to be molybdenum. For some reason that's hard for me to say, 4 hypochlorite. So you have to have 4 of these, because each one of these here is going to be -1, and the molybdenum is +4, as we can see here from this Roman numeral, so we have to have 4 of these to match. Next slide. Next. And that's it. All right, so 30 minutes roughly, not so bad. So we finished the whole chapter in like 2 hours, so that's okay. So the next chapter we'll be dealing with will be chapter 3, so I'll see you then.